problems from 3.07. So, hi guys, I'm going to show you how to do these two problems from 3.07. So the first one, we've got a box and it's on an incline and it's resting, it's at rest. And so what they're asking us to do is figure out what the force diagram would be. So first, if you look, you see, oh boy, you see that they took the X and the Y axis and they tilted it. And you can tell that there's going to be some gravity on here, and there's normal force. So our normal force points up that way. And then there's some friction, and the friction is opposing this guy here. So the friction's going to go that way. And so when you look down here, we can get rid of a couple. So we can get rid of this and this because it's on incline, we know that our force diagram should be shifted. It should be rotated a little bit like they rotated this XY axis. So the only thing we need to figure out is what the value of force of friction should be and what the value of normal force should be. Well, come on. Okay. And so basically, because this is at rest, we know that its net force needs to be 0, which means that this angled force, which is gravity, hold up. So this force, which is pointing straight down, but technically we have to break up because now it's not pointing straight down in terms of this XY axis. We have to look at, oops, sorry. We have to then look at the components. So that component is 40 down, so that means normal force is going to be 40 up. This component is 30 over, so that means force of friction is going to be 30 as well. So when you look down here, we've got force of gravity going down in both of these. Force of friction is 30 in both of these, and then normal force is 40 here. Over there it's 50, so that's wrong. This is the correct answer. I know it says explain. I've already verbally explained why, and you guys should just explain that yourselves. Okay. The next one is similar. So we've got our 10 kilogram box. It sits at rest on an incline as shown. We're going to draw the force diagram. So first of all, I'm going to draw my little box. And I like to draw just the components. So this is, that's the force of gravity, X, and that's equal to 57.4 newtons. And then going down, we've got that guy. So we've got force of gravity, Y, and that's equal to 81.9 newtons. Okay, so we must have something because it's at rest. This is F net equals 0. So we must have something pointing this way, and it must be 57.4 newtons. And then we must have something pointing up, which must be 81.9 newtons. Okay, this 57.4 is the force of friction. And then this 81.9 is normal force. So we have 57.4 and 57.4, those cancel out. 81.9, 81.9, those cancel out. The only reason that the force of friction has to be 57.4 when this is 57.4 is because we know it's at rest. Okay? And it is not moving yet. If it was moving, if it was speeding up, then the force of friction would be different. But that's how we know they balance out.